Hello everyone, it's Mr. Kissinger at the Citizenship Academy in Syracuse, New York, and this is 5th grade math module 5, lesson 19. We're going to be drawing kites in squares to clarify their attributes and define kites and squares based on those attributes. So we're probably all pretty familiar with what a square is. That's a quadrilateral with 4 right angles and 4 equal sides. But a kite is probably going to be a new figure for us. So we're going to kind of explain what that is. We'll start with this question 1 here. It asks us to draw a kite that is not a parallelogram on grid paper. And kites are going to be quadrilaterals that have 2 consecutive sides and equal side, or 2 consecutive equal side lengths, and then 2 remaining sides of equal length as well. So whereas a rectangle has opposite sides that have equal lengths, kites have consecutive sides with equal lengths. So if we were going to draw one here that is not a parallelogram, we're not going to be able to really follow the grid paper on here, but we can kind of use it for the top here. So these 2 sides are both 2 units. And then we're going to meet at kind of a point in the middle down here. And it's going to look just like a kite, like kind of like that you would fly. So I'll make this the middle point. This is kind of like 4 triangle lengths here. This is like 4 triangle lengths here. And so this side and this side, these 2 right next to each other, 2 consecutive sides are equal. And then these 2 sides here, the other 2 sides also have equal lengths. So next it's asking us to list all the properties of a kite. There's a lot of properties that we could list, but I'm going to just list the defining properties. First, the kite needs to be a quadrilateral. So a kite is a quadrilateral. It must have 4 sides. And as mentioned, it needs to have 2 consecutive sides of equal length. A kite is also going to have 2 remaining sides of equal length. So the other 2 sides will have an equal length to each other. All right. And we have some other attributes like this angle and this angle are always going to be, we're going to have 2 opposite angles that'll be the same, but as long as it follows these 3 attributes, those 3 properties, you can bet that it's going to be a kite. So we'll leave it at that for now. And letter C asks us is when can a parallelogram be a kite? So think about what a parallelogram is. A parallelogram has 2 sets of parallel sides. So this one would not be a parallelogram. Because we have this line and this line aren't parallel, this line and this line aren't parallel. We don't have any parallel lines in this kite. But we could also make a kite with all of these properties where we have 2 sets of parallel lines. So if we had a parallelogram that was also a kite, it would look kind of like this. I'm trying to draw the best I can here to make all these sides the same length. Because if we had all sides the same length, and we had this side and this side were parallel, we had this side and this side were parallel, then we would have a parallelogram that's also a kite. And what this shape would also be called is a rhombus. So a rhombus is a parallelogram that's also a kite. All right, let's look at number 2 here. It says if rectangles must have right angles, explain how a rhombus could also be a rectangle, or could also be called a rectangle. So rectangles must have right angles, and a rhombus is a parallelogram that has 4 sides of equal length. Well, a parallelogram with 4 sides of equal length says nothing about it not being able to have right angles. So we would make a rectangle. And a rectangle already has 2 sets of parallel sides. It just has right angles. But because it's a rhombus, all the side lengths would also need to be the same. So we would have 4 right angles and 4 equal sides. And we would have this side and this side would be parallel. We would have this side and this side would be parallel. So what we have here is a square. So a rhombus could also be called a rectangle when it's a square. So a rhombus is also a rectangle when it's a square. Number 3 asks us here to draw a rhombus that's also a rectangle on the grid paper. So it's really just asking us to draw a square here. I'm doing my best. I'm not really going to be able to use the grid paper here fully because we don't have the right directional lines for this. But if we have all sides the same length, and we have all angles at right angles, we have a square. And that's a rhombus that's also a rectangle, which is a square. All right, let's look at the next page here. This one says, Kirkland says that a figure EFGH below is a quadrilateral because it has 4 points in the same plane and 4 segments with no 3 endpoints collinear. Explain his error. So this does have 4 line segments, and even though it has 4 line segments, it's not a quadrilateral. Right here, our lines cross. So the lines of a quadrilateral cannot cross this creates two closed figures. What we really have here is two triangles. Here's a closed figure right here, and here's a closed figure right here. And we really have a point right here we could add where they intersect. We could call it E, F, G, H. We could make this point I if we wanted to. And it would make it triangle EFI and triangle GHI. And we'd have two triangles there. But it's not a quadrilateral because those line segments cross each other. And we have a point of intersection, and it's not a singular closed figure. So that one's kind of a weird one, but we understand kind of where he's coming from there, just because it has four line segments. But here we have a kind of a mini line segment. Here we have a mini line segment where those two cross. We have to also call that some sort of a point. So we're going to stop there for today. Thank you guys for tuning in, and I look forward to seeing you next time.